The following is the learning objectives and details of this module. Please read it carefully, and let's start. Before we carry out the circuit diagnosis, we are going to learn how to use the tools that are essential for diagnosis. The tools we are going to learn about are test lamp, multimeter, hook-type ammeter, and VMI. First, we are going to start with the test lamp. The test lamp is composed of a housing that includes a light bulb or LED, a probe to put onto a part, wiring of suitable length, and a clamp at the end of the wiring. You can engage the clamp to the vehicle body, which is the ground, and put the probe onto different locations to see if voltage exists on the location. If voltage exists, in other words, if the circuit is connected, the light bulb or LED turns on. However, you cannot precisely measure the voltage using the test lamp. Of course, you may estimate the voltage by looking at the brightness of the light bulb. But if you need to know the voltage precisely, you should use the multimeter. There are two types of test lamps, a light bulb and LED. It is classified depending on what the light source is. In the case of an LED lamp, you can also measure a small amount of voltage, but this may lead to the misinterpretation of circuit condition. What should you bear in mind when using such a test lamp? You need to check if there is anything wrong with the test lamp before measurement. Since the LED or light bulb has a finite life, you should check if the test lamp functions normally before measurement. We will learn about the multimeter. The multimeter is one of the most powerful and basic circuit diagnosis tools that can be used to measure current, voltage, and resistance on the circuit. In the past, voltmeter and ammeter have been used separately to measure the current and voltage, but they are rarely used these days. The multimeter is divided into digital and analog types. First of all, the analog type uses a needle and printed numbers to indicate the value. Therefore, it is hard to read the precise value, and the tool is vulnerable to outside shock. Also, it has relatively small resistance as a measurement device, so its precision is rather low. So it is rarely used these days, just like the voltmeter and ammeter. On the other hand, the digital type provides easy-to-read measured values and has relatively good durability. Also, it has high internal resistance, so the measured value is relatively precise, and the tool does not affect the existing circuit. We will learn about how to use the digital multimeter as we operate the device. You can rotate the rotary dial located at the center and press the button to select the functions you want. Next, we are going to learn about the terminal jack. Generally, there are a total of 4 terminal jacks at the lower part of a multimeter. COM terminal, located at the bottom right, plays the role of common ground. The terminal at the top right measures the voltage, resistance, and capacitance. Also, 2 terminals on the left are used to measure the current. Since rated current is indicated on the terminal, you should select the terminal that has a higher current value than the estimated current to carry out measurement. Also, a fuse is installed inside the multimeter to prevent overcurrent that may occur during the measurement. Click on the tip button to see precautions for using the multimeter. Now, we are going to use the multimeter and measure the voltage. We will measure the voltage on the A point in a DC circuit. Select the DC voltage. Locate the black probe on the vehicle ground and COM terminal. Locate the red probe on the A point and check the measured value. This method is used to check the voltage difference between the ground and the location you want, in this case, the voltage at the A point. We will measure the voltage difference between A and B points. Select the DC voltage. Locate the red probe on the A point. Locate the black probe on the B point. For your information, the black probe is usually put on the place that has a lower voltage. This method is used to check the voltage difference between 2 points. In other words, to check how much voltage is used between the 2 points. We will measure the resistance of the component. First, select ohm. Locate the black and red probes on both ends of the resistor and check the measured value. At this time, resistance is not measured directly, but rather measured indirectly by applying a little current inside the circuit and measuring the voltage drop that occurs. There are two important points you should know. First, since the measurement is done using a little current, it is difficult to measure resistance that is below 1 ohm. In order to precisely measure the resistance that is below 1 ohm, a special equipment called milliohm meter should be used. Second, since this method indirectly measures the resistance, separate power should not be applied to the circuit. Therefore, when measuring the resistance on the element inside an automobile circuit, the ignition switch should be turned off. Click on the tip button and see what kind of symptoms occurs when resistance is measured while the ignition is turned on. We are going to check the connection between A and B points. First, select beeper. Locate the black probe on the A point. Locate the red probe on the B point and check the beep sound. We will measure the amount of current that flows through the A point. The multimeter should be inserted into the circuit in series. First, for the safety, cut off the power when measuring current. Select the DC current. Disassemble the circuit. Connect the black and red probes. Apply current on the circuit. If more current than expected is applied to the circuit at this time, the circuit may be damaged. In this case, the fuse inside the multimeter blows out in order to protect the whole circuit. Next, we are going to briefly learn about hook-type ammeter. Current measurement should be carried out in series with the circuit. That's why a circuit disconnection is necessary. However, it is rather burdensome. So you may use the hook-type ammeter. To use the hook-type ammeter, you need to clamp it around the part you intend to measure. This method does not directly measure the current. It is an indirect measurement by using the magnetic field generated by the current. Therefore, as the current on the nearby wiring can generate magnetic field as well, precision is lower than the direct measurement. Accordingly, you need to protect the hook-type ammeter from the interference due to other wirings when you carry out measurement. The hook-type ammeter is usually used to measure comparatively large current, such as that of an alternator. You can measure the voltage and resistance by using the GDS device. By using the bottom menu in the GDS program and the VMI module, you can measure the voltage and resistance just like using the multimeter. Also, you can measure the changes in the voltage with the corresponding waveform as time goes. In the case of an injector, ignition coil, and PWM signal, the value that changes in time is important. At this time, you should analyze the waveform instead of simply checking the voltage. Next, we are going to learn about cable connection of the VMI module. First, prepare the GDS laptop, VMI body, and various cables. Connect the VMI body and GDS laptop with a USB cable and connect the vehicle battery and the VMI with a power cable. Select DVOM or oscilloscope menu on the GDS program and locate the probe pin on the part you wish to measure. For your information, this process does not have a particular order. Please refer to the manual for more details about using GDS. Please review the lessons you've learned in this session through simple quizzes. Please review and memorize the contents you have learned so far.